Hey friends, my name is Carl Gabriel D. Santos, and I will be teaching you about work. So, let me tell you first, what is work? Well, work is the thing that creates energy and allows us to do something. So, an example of that is lifting up a dumbbell. So, this is an example of work because when work is being created, there's also energy being exerted. So, every time I lift this dumbbell right here, obviously I'm using energy when I lift it. That's why I get tired after. So now, what creates work? As I said earlier, when there is energy being done. There are also other examples of work, like for example, running, typing on a keyboard, because obviously there's energy being done there because obviously you're using your fingers there, lifting up something like what I did here, and many more. But if I do this, as you can see, the dumbbell's not moving. This is called a constant. This is called a constant motion because, as you can see, it's not moving. But it's not moving unless I want it to move. But if I want to move like this, I'm exerting energy. I'm exerting energy to it. So that is an example of work. So let me give you this example. There's also not work being done. Let's pretend you're pushing something heavy, like a chair, or something like a heavy box that has many things inside it. For example, we have a box that has all of your family belongings in it. And then you pull it like this. Like I pull it like that. Obviously, work is being done because, again, you're exerting energy. But there's also something else that's being created. Well, there's also a thing called friction. So you may ask, what is friction? Well, it is created when two objects rub into each other like this. That is friction. But as you can see, there's the dumbbell right here. It's really heavy because its mass is very heavy. Again, here's a dumbbell, obviously. Many weightlifters lift this. So when I push it around like that, it's gonna be really hard because when I push it around like that, this is, for example, work. This is work, and friction pushes it the opposite way, preventing it to slip around like that. So, like this. When I push it like that, work is being done, but it makes me hard to push because of friction, pulling it backwards. That's why work is becoming negative when friction is pushing it. Okay, so let me give another example. When you were a kid, have you ever tried, like sliding on the smooth tiles on the mall? Well, that happens because when a smooth or slippery object is being rubbed into each other, there's less friction. You may ask, why? Because there's less interlocking of friction in the object if it's slippery, obviously if it's slippery. But if the surface is rough, then it interlocks more with friction and creates more. That's why when I try this on as I showed you, a rough object, it doesn't even slip. So I'm just gonna go to my kitchen real quick because there's a smooth surface there, and I'm gonna try to push this there, and let's try if there's friction or not. So this is an example of friction rubbing into each other to create it in a rough surface. So I'm gonna go with my finger first, and obviously I'm gonna try it on a rough surface. As you can see here, very rough. It's really hard to slide. So let's try it first. As you can see, there's some force stopping me that's creating my finger to hop over like this in a manner. As you can see, it's hopping around, not doing anything, because there's friction interlocking with our work, and that is why it's causing us to hop. That is why our finger is causing it to hop, because our friction goes the opposite way, which means our finger is going to trip. That also goes with our shoes right here. Obviously, if I try and slide here, do not try this at home. I almost fell there because of friction. As you can see, friction creates an opposite direction than force. It's the opposite energy. So it pushes me backwards, that's gonna make me fall. So let's try this with water. Alright, now I got a bucket of water here, and I'm gonna sauce my hands here. I'm gonna dip my hands to become here really wet. As you can see, it's getting all over me. And now, it's raining right now, sorry. This is a way smoother surface because it's wet, obviously. This is a rough surface, so now we're gonna try. As you can see, with no effort, my fingers just glowed. It just glided on the surface. Look at this. Not even a scratch. But when I try my other finger, it's pretty hard, as you can see, because my wet finger, my wet hands has less friction because there's no force or no friction interlocking with this, because it is not interlocking with friction. As you can see, it doesn't even hop around, just glides. But with my dry fingers, as you can see, it's still the same as our other experiment right there, where the friction was activated. It was pulling down or preventing my finger to slide because there was literally no smooth surface or smooth area that it can interlock less. So what that does is this is what you call, you know, the area that is very much doesn't have like that much friction. It just doesn't slide because, again, it's a rough area. So that's how it works. So now I got my whiteboard over here because now you may be asking, what is the formula to get work? Well, the formula is work equals force times displacement. So this is our formula to get work. So let's give an example. So let's pretend we have, let me say, 20. Let's say I have a force of 20 and then a displacement of 10. So as it's said on the formula, we have to times, we have to multiply it. So obviously, just try to grab your calculator, grab your calculators, or you can solve it mentally. And I'll give you seconds to solve this. Alright, so obviously we're going to multiply it. So 20 times 10 is going to be 200. So it's going to be 200 force meters. Or let's say, because this is not the correct way, it should be 200 joules. So we call force, when we get the answer, newtons, right? Well, we call work joules. And this is the spelling right here. This is what we call it instead of newtons, or this, because this is way easier to use and the correct way to do it. So if we try that same solution or the same formula, but there's friction now, obviously it's going to be a way different. Sorry, you can fact check it right here. This is the example of that. But work has many more energy than kinetic and obviously the other energies. There's also mechanical, nuclear, and heat, and many more. So there are a lot more energy right there that can, you know, make work. Like for example, we have so let's example factories, for example. As you can see, have you ever went to like Gardenia? Have you ever went to the factory there? They're like machines that control the bread that goes there, or like a local bank or something. Like they print out the money, the machines push it like that. That creates work. Now let me tell you why. It's called mechanical energy because it's creating by mechanics or machines, but it's creating work because there's energy being consumed. And what is that energy being consumed? Obviously, it's going to be mechanical energy. Same thing with cars. Cars create work too because their energy, you know, there's also mechanical energy. They have engines and stuff, and their what do you call it? Tires. When they rub in to another surface, it creates friction. That's why our cars, like, when we stop a car, let's pretend there's a car, when we stop it, it pushes like that, right? It pushes like that, and then it creates like your seats just like, just pushes back, and then like all your family members would be like laughing and screaming. Yeah, that happens to me. But that is also an example of friction and work and energy. So here's my last question. If friction is that much of a pain in the butt, where it just cancels everything, it doesn't make you slide, why is friction important then? Well, if we have no friction, if this world is frictionless, then possibly everything here would not stay as constant. So what do I mean by that? This chair right here is not moving because it's constant. But if it's a frictionless world, this chair would be moving everywhere when it had an earthquake. So let's make a scenario where there's an earthquake right now and everything's moving. This chair would like be, if it had like friction and stuff, it would just like shake and then stay in its position, right? But if there was an earthquake in a frictionless world, the chair would move everywhere, like go there, go there, go there, go there. Because there's nothing pushing it back, it's just going to keep sliding on whatever surface it is. So basically, it's just like ice skating, but everything's shaking, and yeah, basically the world is basically just ice skating. So a better example of that is ice has no friction, because again, it has water. Friction creates less, water creates less friction. So let's pretend we have an icy surface, and let's try and slide a chair. However heavy this chair is, it's still gonna slide because there's no friction or less friction being created because it's not interlocking when they're rubbing each other because it is slippery. So that's what happens when there's no friction, just everything slides. So that's a perfect example of that. So that's all for today. You can watch whatever, I guess, but there might be like better examples or teachings that people have, but this is kind of optional. And you know what? That's it. Thank you.